Welcome to a lesson on how to determine the distance between 2 points. The distance between 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, is given as d, the distance, is equal to the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Now, even though this formula looks quite different from the Pythagorean theorem, it is a result of the Pythagorean theorem. So I'd like to take a moment and show where this formula comes from. We know if we have a right triangle that c squared is equal to a squared plus b squared, where c would be the length of the hypotenuse and a and b would be the lengths of the two legs. So this would be c. Let's go ahead and call this leg a and this leg b. If we wanted to determine the length of hypotenuse c, we could solve this equation for c by taking the square root of both sides. So we would have c would equal the square root of a squared plus b squared. Now remember that a is just the length of this leg here, and b is the length of this leg here. Now if this right triangle was on the coordinate plane, we could call the coordinates of this point x1, y1, and we could call this point here x2, y2. Well, notice that the length of this side A would just be, notice the length of this side A would be determined by the distance between x sub 1 and x sub 2. So A would be equal to x sub 2 minus x sub 1. And the length of B would be determined by the y coordinates of these 2 points, which would be the difference between y sub 2 and y sub 1. So B would be equal to y sub 2 minus y sub 1. So the only difference between the Pythagorean theorem as we see here, solve for c, and the distance formula is we're substituting x sub 2 minus x sub 1 for a, and we're substituting y sub 2 minus y sub 1 for b. So if we perform these substitutions, we'll have the exact distance formula we just showed on the previous screen. So let's go ahead and do it. Instead of c, we'll use d for distance. So now we'll replace a with x2 minus x1 squared plus, now we'll replace b with y2 minus y1. And we have the exact distance formula as we saw on the previous screen. Now let's go ahead and do an example. We want to determine the distance between the points -2, 9 and 3, 4. The first thing I like to do is label the coordinates of these points. I'm going to call this x sub 1 and this y sub 1. And I'll call this x sub 2 and I'll call this y sub 2. It doesn't matter whether we label these the 1s or the 2s, but if we call this x sub 1, we do have to call this y sub 1. We can't interchange the 1s and the 2s within a given point. Okay, so our distance should be equal to the square root of x2 minus x1. That'll be 3 minus -2 squared plus y2 minus y1. That'll be 4 minus 9 squared. And now we need to simplify this. Well, 3 minus -2 will become 3 plus 2, so this will be 5 squared, plus 4 minus 9 is -5, so we'll have -5 squared. Well, 5 squared is 25, and -5 squared is also 25, so our distance is equal to the square root of 50. Now at this point, it really depends on what class you're taking. If we just want a decimal approximation, we can go ahead and type this into the calculator in this form. Let's go ahead and do that. We're going to type in the square root of 50. And let's go ahead and round to 2 decimal places. So we'll say it's approximately 7.07 units. However, if your instructor wants you to write this in simplified radical form, remember you can rewrite 50 as 25 times 2, well, the square root of 25 would be 5, so the simplified radical form for the square root of 50 would be 5 square root 2. And again, it just depends on what class you're taking and in what form they want the answer. This is simplified radical form, and this is the decimal approximation. Let's go and take a look at this graphically. Again, we said this distance here was approximately equal to 7.07. Notice the horizontal distance here from -2 to +3 would be 5 units. The vertical distance here from 4 to 9 would also be 5 units. Now just to do a quick comparison, if we wanted to label this side C for the hypotenuse and use the Pythagorean theorem, we should obviously come up with the same answer. We would have C squared equals, let's call this A, so we'd have 5 squared plus B squared, which would be 5 squared again. So we have C squared equals 25 plus 25, which is 50. And so we have the hypotenuse would have a length of square root 50, which we just showed on the previous screen was approximately 7.07. Okay, I hope you found this video helpful. Thank you for watching.